Today we'll complete the OSPF portion of the routing on IPv4 as well as IPv6. We have started this discussion in the last session. We did discuss about the different routing table. The primary one is INET.0 and INET 6.0. Then we did discuss about the route preference. For direct and local we have 0, and static we have 5, and OSPF we have 10. So this forwarding table is one of the concepts that we have. From the routing table, the forwarding table is calculated, and forwarding table can be visible with the help of this command show route forwarding table. There is a concept of routing instance as well. Then we have null routes. So if you want to drop a particular traffic, we can create a null routes with that. The next hop will be null in this case. Active route. So if it is marked with asterisk, it is counted as active route. How we make a static routes in IPv4 and in IPv6. So in IPv4 we have a static, under routing option we have static route. Then 0, for example, if it is a default route, it goes like this: 0.0.0.0/0 next hop particular IP address, or else we can have a specific route like this. No advertise option is there, and it is described here. If suppose I don't want to re-advertise this in any other routing protocol, like in OSPF or in RIP or in BGP, right? So we can use no advertise, re-advertise message. How we verify the routes show route protocol static. Let me check if we can run this command. So we already have VMX router open. Let's restart it. So show route protocol, we can go with static, right? So static routes will be visible, or else we can go with show protocol OSPF. So I have configured OSPF from VMX to R2, R3, R4, and R5 is still pending. How we configured static route with routes which are not directly connected, or which is not resolved directly. So you can see here on a router A, means the first router, we have added a static route here 172.20.3.0. Where it is present beyond router C, right? And the next stop is 172.25.1.6. So 25.1.6 is somewhere here, which is not directly connected to router A. So we need to resolve it, right? So first of all, we should have a route for 172.25.1.0 or 1.4, right? And through that route, we can reach to router B, and router B to this particular interface, and from there we can reach to this IP address. So that's something called as resolve. Qualified next hop, if you want to have a floating static route. In CCNA, we have a floating static route concept, and here we have qualified next hop concept. Any idea, guys, what is floating static route? Have you implemented in the past? Okay, similar concept is there with qualified next hop, but here we have to keep the preference inferior to the standard one. What is the default preference or default AD value in static? In case of default static root, we have preference level 5, right? But here we have kept it 7. So if the primary next hop fails, then the secondary next hop will start working. Is it clear, guys? If you keep this preference value same, then that's not going to work properly. Static routing and dynamic routing. So next concept that we have to discuss here is static and dynamic routing. We can test this particular concept in our practical. We'll see if time permits. We'll come to this portion as well. Dynamic routing and static routing. If you do comparison, for a small network, we prefer static routing, or you can say for fixed network also, we prefer static routing. And if there are changes, dynamic changes on the network, right? So dynamic routing is a preferred one, especially the large network. The other benefits of dynamic routing: lower overhead of the administration, then stability and availability also increases with that. Then in the dynamic routing, we have further more categorization as IGP and EGP. So, which one is the best IGP protocol? OSPF is mostly used, right? So we can say industry darling protocol is OSPF, right? And EGP, we don't have any option other than border gateway protocol or BGP in case of EGP. In OSPF is similar in Cisco one. In OSPF, configuration is little different, but the concept is similar. Here also we have LSA. Here also we have LSDB. Here also we find the path by shortest path first algorithm or disastrous algorithm. The configuration goes like this. So I have done this configuration on one of the router. First, I'll show you what I did on R2 on the Cisco, and then I'll show you on the VMX end. So you can see here, I kept the process ID 1, then router ID 2.2.2.2, and this is the blanket statement covering all the interfaces. So here I have two interfaces, show IP interface. One is a physical interface F00, and the other one is logical interface loopback 0 with the IP address 2.2.2.2, right? And this blanket statement enable the OSPF on both the interfaces. That also we can confirm, show IP OSPF interface brief. And so both the interfaces are participating in OSPF packets. And this forms the neighbor relationship with VMX router. So VMX router has a router ID of 1.1.1.1, right? And state is BDR. It means R2 itself is a DR, right? Now let's go to the VMX and let's check the configuration. Show configuration. First configuration section is system. Second one is interface. Then we have routing options. So in routing option, we have RIB INET 6.0, which is for IPv6. And we have static and then we have protocol. Under protocol, we have OSPF, right? And under OSPF, we have area 0.0.0.0, right? And we have configured it with interface GE000. If you want to see this in the set display option, so we can see that this option, and you can see this is how we need to set the OSPF protocol. So we did it for GE000. Same we have to repeat for GE001, 2, 3. Okay. So let's go to the configuration mode. Before doing so, we should set up the router ID with this option, set routing option router ID 1.1.1.1. So I'll enter into the configuration mode, and then we'll run a command set protocols OSPF area 0.0.0.0. In Cisco, we use area 0 only. Right, if you see here, we specify area 0, but in reality, this area 0 is 32-bit. So if you expand this in the proper format uh, mentioned in IETF documentation, it goes like this 0.0.0.0, right? And after that, we have to specify the interface. So we have GE001.0. Let's repeat it for 2.0, and let's repeat it for 3.0. Okay. We run command show, compare. You can see we have added all these interfaces, right? And let's commit this. Right. So because of this, now we have OSPF implemented on all of the interfaces. So hello packets are shooted from all four interfaces. Now we have to configure OSPF on R3, R4, and R5. Let's start with R3. Should enable a OSPF between R3 and VMX. You should get a neighbor relationship formation message here. Okay, so we are working as two-way, then DR others, and now we got the message. Right now, 1.1.1 is DR and R3 is VDR. Let's do the configuration on R4. We formed a neighbor relationship. R3 also will run a WR, and let's run OSPF on R5. R5 means 5.5.5.5 and network is over all the interfaces. Yeah. Now, if we check the routing table, show IP route, all the OSPF routes are visible. Furthermore, this static route is also there, but static route with the AD value of 1 and OSPF with the AD value of 110 in Cisco. Why we can see OSPF route if static route is there? This is a question of routing. This is not about the Cisco only. If we have a static route with the AD value of 1 and OSPF route of 110, why we have the OSPF routes available if static routes are there? Any idea, guys? You understood my question? Before AD value, what we have to see? The specificness of the network. Here you can see the specificity of the network is /32 here, right? So which is or /24 here. So if you have a more specific route, correct, longest prefix match is there. That's why default route is counted as gateway of last resort. This is not the first option. This is the last option, right? Whereas in VMX router, we already have a specific routes. Let's check. Show route. So here we have static routes and we have direct and local routes. But if you consider the inet.0, right? Here you can see 2.2.2 is available via static route and it is also available via OSPF, right? Then this star makes more sense. Now what this star is signifying here? So even though you have two options to receive this information, which one we are preferring? Because of preference value, we are going with this one. Correct. We are going with the static route. Correct, Abhishek. This is pointed as an active route. And why the static route is active? Because the preference is 5. And here the preference is 10. Right? And lower value is preferred. In Cisco terminology, AD value is 5 here and AD value is 10 here. If we lose the static route or if you remove the static route, then this value become a active route. I hope it is pretty clear for all of you now. How we do the configuration? So under edit protocol OSPF, right? Area 0 and interface GE001 001.0. So this is a configuration portion. In IPv6 routing, we have to first set the IPv6 addresses. Right? First, we need a IP 128-bit address, and then we need a prefix. Normally, this prefix is /64, right? So when you give this IP address, enable the IPv6 and give the IP address as well on the interface. What other options we need to consider on IPv6 interface configuration? We have /64 prefix in a normal network, in the multi-access network, like a switch is connected on that. Or if it is a point-to-point link, we have to keep it /127. What is the preferred slash subnet mask or slash notation subnet mask in IPv4 for point-to-point link without wasting the IP address? In point-to-point link, Akshay, /24, we can keep it as for the normal network. In point-to-point, we normally go with /30, but we can go with the lower than that also, like /31 or /32. But the more preferred one is /30 most of the time, and we can go with the lower values also. It depends on the platform also, but in the practice we have seen /30 most must be /128 for loopback address. What is a loopback address in IPv6? In IPv4 we have 127.0.0.1, right? And in case of IPv6, we have /128 colon 1 colon 1/128. It's I write it here. It will be like this: colon 1/128. Okay. If you don't want to give IPv6 address on your own, you want to get it on MAC address basis. So first of all, we can enable it with set family INET6, or else we can set it with set family INET6 address, and the network prefix we will specify after that colon, and then /64, and at the end EUI64. So whatever MAC address we have, on the basis of that, we'll get the interface ID. How we set the IPv6 route? So for that, under routing option, we need rib inet 6.0 and then static route. So this we have already configured. So set a routing option, rib inet 6 static route, right? This specific loopback address network we have added, and then we have specified the next hop IP address. Similarly, OSPF v3 can also be enabled. Only change that we have to make here is edit protocol OSPF 3, right? So let's try this on VMX. First of all, we'll go to the configuration mode, and then we'll go in the edit protocol OSPF 3. And under this, we will set area 0.0.0.0 and the interface. So we have a loopback interface also here. And we have other 4 interface like GE 0.0.0/0/0.0. Then we have 1.0, we have 2.0, we have 3.0. Right? Let me go to the top of the hierarchy, show, compare. So we have enabled it on all 4 interfaces. Router ID is already set under routing options, so I don't think there will be any problem on that. Okay, comment done. Now let's enable OSPF version 3 on the Cisco routers. So we'll go to router 2 first. IPv6 unicast routing first, then IPv6 router OSPF 1, and router ID we can specifically mention 2.2.2.2. Then under interface we have to enable the OSPF. So interface loopback 0 we have IPv6 OSPF 1 area 0, and let's repeat this for F0/0. So this will form neighbor relationship on OSPF v3. And let's repeat the same thing for R3. For the loopback interface first. Then for the gigabit interface, fast Ethernet interface. Repeating the same procedure. I hope you guys are following this. IPv6 OSPF 1 area 0. So now this neighbor relationship on the central router we can analyze from the image. Let's exit from this. Show OSPF neighbor. So all the neighbors available with the router ID 2.2.2.2, 3.3.3.3, and 4.4.4, and 5.5.5. If we check the routing table, show route, we can see the OSPF routes. Right? So you can see here the next available option is OSPF 3 with the same preference value. Clear, guys? Any doubts so far? That's it on today's session. I don't have any further topics for the day. Rest of the points we will cover up in the next session. Okay, then see you in the next session. Yes, Akshay, I'm adding few more points on this. Most probably by tomorrow, I'll upload all these things in the Google Drive. Okay, guys. Good night. Bye.
Good night. Bye bye.